Hello, it is currently 23rd of March 2024, and this is the video guide for the Rveg R package for transcribing phytosociological relevance to digital format. I have already made one video that you can find here on this channel, but I find it insufficient and too rushed, so I'm creating a new one where I will explain the package in more detail. Alongside this video, you can use the PDF manual user guide that is part of the package. You can easily find it through the command Rveg, or you can use prepared executable script that is downloadable from the description of this video. The video will also have timestamps for each function that is part of the Rveg package. To start, you have to install the package, which is possible through two ways. You can either download it from the official repository of CRAN, where will be the latest stable version, but sometimes you might find useful download it from the GitHub repository, where the minor bug fixes will be introduced first. So we can try that right away, downloading from the GitHub, and we will load it to the library as well. Let's take a look on the structure of the package. Here you can see some description, and if we go to the index, we can see all the function that is part of the package. So we'll start with the first one, the most important one, add relevant, and then I will present the other ones as well. So enjoy the video. The function add relevant is the most important from the package because it allows user to transcribe the relevance to digital format. Now I'll show you the parameters that are in the function, and then I'll show you step by step how you can work with this function. Let's see. Add relevant has 4 parameters, starting with database. That one is for the editing already existing database. So we'll leave it at default, but we need to make argument save, which is how our new database will be named. So let's name it as video guide. Then there's another parameter checklist. That one is used for using another checklist than the default one. And last parameter is extra head if we want to add some extra parameters, extra characteristic to the header of the database. So we'll go with just this, add relevant save video guide. This will make the new database in our working directory named video guide. Let's run this, and it will immediately start writing the first relevant through the interaction with the user. There is a set of predefined header characteristics, but none of them are mandatory, and you can add your own as well, but we'll go along with the predefined set. So the date, as I mentioned, it's 23rd of March. If we do not wish to fill any characteristic, if there was no record of it, you can leave it blank. We will make a fictional relevant right now for the explanation. You can see all the characteristics that I am filling. None of them has any set format. You can fill it as you wish, but you might be thinking about compatibility with your other projects. So I recommend to use the same format all the time, but all of these are just recommendations. So I'm just now making total fictional values just to show you how the package works, but you will use, of course, your noted one. So no slope, exposure, E3 is for the coverage of the tree layer. Let's leave it 0. Shrub layer also 0. Let's say our releva is some grass, no juveniles, and very low percentage of moss layer, and no node. So by this way, you can fill the header of the first releva, and now we get to the part where we are filling the species. So I'm interacting with the Rveg, and I'm getting asked if I want to add new layer. I say yes. I specify that it will be the herb layer, and that my values will be inserted with percentage. Now, the way how Rveg works is that the species from the checklist have created 7 letters short name codes. Each species has unique code, which significantly increase the speed of the writing. So if I would be about to write, for example, species Silene vulgaris, I have to write the 4 letters of the genus name and 3 letters of the species names. So Sile vul, let's say it was 3% of abundance, and I have to double check that I meant this species. So for me it's yes, and I see right now in my first releva there's 1 species of Silene vulgaris with 3% of coverage. The same way I can add as many species as I want. So I will add some more species. For example, Sanguisorba minor with 5%, Senecio vulgaris with 1%, Viola odorata with, let's say, 3%, and so on. What can happen is that some species have different names, have different codes, then it would describe the name. This can happen when one code would be suitable for more species. So one of the species have to have different codes. So in that case, if the code is not incorrect, you can search for it right in the Rveg. For example, I want to add Erodium cicutarium with 10% of coverage, and I see there's none species with that code. So I insert 3 letters of the species, and I found the correct name in the list. So Erodium cicutarium is Erotceu, as I can see here. So I enter the correct code and confirm. Another thing that can happen is that we are not sure about the species, but we recognize the genus. So for example, I recognized Papaver species, but I'm not sure which one. So in case I want to insert Papaver species, I would use the SPA at the end of the instead of the species names. Let's say 1%, and I see Papa. Espa is Papaver species. I confirm. Another thing that we might want to use is to use of aggregates. So for example, Achilla millefolium aggregate. I'm not able to recognize which species it is. So I write Achi for Achilla genus, hashtag, and the name of the aggregate. So ME millefolium 10% again, and I see it's Achilla millefolium aggregate. I confirm. So basically, the species are characterized by the ending of SPA and aggregates with the hashtag. There are also another, for example, the hybrids are usually noted with the star. So let's say this is our first releva. I don't want to add any more species, so I said no. I do not want to add any new layer, but I'll show you how it would look like. I would just need to select another layer, let's say shrub layer. Now we can try inserting in brown blanket scale. It's no problem because the values are after converted to percentage anyway. So let's say in our releva was also some rosa species at plus coverage. So I can see it that I confirm and I see it was added to the releva. It is distinguished by the ending that it is in second layer, which is the shrub layer. In a case I make a wrong input, I can simply remove the species from the releva by giving it 0 coverage. So I'm going for Rosa Espa because it was not in reality part of our releva. So I'm giving it 0 cover and I see it disappear from our releva. So I don't want to add any more species. I do not want to add a new layer. And I get prompt how many species was recorded in the releva. That's good for checking if we didn't miss any. But I might want to add another releva to our database. First, let's take a look how the database look like. The function add releva outputs the Rveg database, which is consisting from 2 files. So our database is named video guide, and it created 2 files, one for header and one for species data. Let's take a look how they look like. It's simple CSV file with which is editable in any spreadsheet software. We can see there is a column with the short names and another column for each releva with species coverage. We'll take a look later after we add another releva, and the same goes for the header. So we see there are the predefined set of header characteristics and the values we inserted. Let's get back to R. We see that after we finished our first releva, we can see that we ended up in some kind of menu where we can utilize much more commands. In case we want to add another releva, we prompt Y and the process repeats the same as before. As I mentioned before, there is no mandatory to fill any of the header characteristics, so I will now just skip all of the values. Let's say I just input my name, but I am not forced to fill anything else, and I will make another fictional releva Let's say now we have the shrub layer, so I will start the shrub layer, and I'll add rows of species I removed before because I made a mistake, and in reality it was in this second releva with the 25% of cover. I can then add some species to herb layer as well. Let's say there was some species Glechoma hederacea, 10%, Centaurea sp, 5%, Poa annua, 4%, and so on. This way I could continue for as many species as I want. You may notice that Poa, because of the genus, has just 3 letters. It is filled with the empty space. So this way I added a second releva. I do not wish to add any new layer, and I ended up in the menu again. Now we can take a look on some other commands. One of them is print head, which is printing me the headers. I can see I have 2 relevas so far, and I can see in the second one I didn't fill any value apart from my name from the author of the releva. The same command is print rel just for the species, so I can see 2 relevas with the species and their coverage. The first column is some ID from the checklist, but that is not any important for us. Okay, now let's say we want to edit already existing database. In that case, we need to fill the parameter database, and we will use the one we made before, called video guide. Because we are in the working directory where the database is present, we can write just video guide, and I'll change the parameter save because I do not want to rewrite my previous database, but I want to make a new one. But it is also possible to rewrite the previous one. And in that case, I would not to fill the parameter save. Let's run this, and we see I immediately ended up in the menu. There are other options, there are other commands I want to show you. It's the rrel and rhead, which is made for the repair, for making changes in the releva and in the header. Let's take a look on the repair rel first. So let's say I want to change the second releva. I'm getting from the header characteristics, so I can check if it's correct. I agree. And I'm getting shown the releva. And way how to edit this is just that I'm adding new species, or I can remove them by adding them 0 value. So let's say I made a mistake when I was typing the Glechoma hederacea with 10% and it was meant to be just 1%. So I'm starting to editing the hair player, and I'll just simply change the cover of Glechoma hederacea to 1. This way we can see it change it in our releva. I do not wish make any changes. I'm getting from the species richness again, and I see I changed Glechoma hederacea to 1%. Quite different thing is when we want to change the header. So I write our head. Let's now make some changes to the second one because I didn't fill anything there. I agree it's the one I want to edit. I want to repair something, And let's say I was also meant to fill the cover of the hair player, so E1, and the cover was 10%. I know to repair anything else, so I would know. And now when I'm going for print head, I can see that the cover of the E1 layer is 10%. So that was about the add relevant menu. Last one I didn't show you is the remove rel, but that one is simple to use. You just need to select the one relevant you want to remove, say the last one, and confirm with the Y. Now our database is just one relevant. The way to end the function add relevant is to either write N in the menu or simply end the function through the escape key. Now let's take a look on another function, create checklist, which is the function that allows us to create checklists suitable for Rveg from the set of species. So I prepared here a new checklist, which in the simple format txt is the set of the species from which I will make the checklist. It's then very simple function create checklist with the species list and export parameters. So for species list, for me it's new checklist, name of the file I prepared, and export will be our new checklist. Let's see what this function make an output. It's our new checklist, and it's in a format now with the full names and short names species codes. So we see for the species it's viola sp, for the aggregate it's with hashtag as we said before, and you can see for a subspecies there is this way of writing. We then can use this in our add relevant function. Next function is function rveg check, which is used to check for the duplicity in your databases and to make an export with the full names. So we can see there are 4 parameters. Database is for the one we want to check. Full names is we want the export to include the full names, name of the exported file, and used checklist. So I prepared here our database video guide. Exporting will be check export and full names will be included. Let's see the results. Now we can see there's check export rel with the full names and both of our relevance. Another one on the list is Rveg combine, which is used for merging the species in the database or merging the layers together. We can try to let's see our database first, and I can see, for example, that I have rosa aspa in the second layer, but I might want to use and analyze it all together as hair player. So I want to merge those. I want to merge the shrub layer to the hair player, and I can see that it changed the layer of rosa aspa to the hair player. In case I would have two two species that I want to merge, which I do not have at the moment in the database, but for example, you want to merge something to the species or to aggregate, I can choose species. And let's say I want to merge, mm, uh, let's see, Villa odorata to with Sanguinea minor, and we can see that Villa odorata actually disappeared from our relevance, and that Sanguinea minor now has occurrence of 8 instead of 5. Another function I'm going to show you is Rveg merge, which is used to combining two existing databases together. It has 4 parameters. X goes for the first database, Y goes for the second, save goes for the output, and if we want to also make a header file with our new database. So I choose to use the video guide, our first database we made, and combine it with our combine export database and save it as merge export with the headers. Let's go for it and check the results. Merge export head and row. Let's take a look. Yes, so you can see now it has 4 relevas from the two databases we merged together. We can see that rows are SPA1 and SPA2 was because in the merge we changed the layer. And the same goes for the header. Now I have 4 relevas. So these functions I showed you from the Rveg package was all about to manipulating and creating the Rveg databases. There are 3 another functions: Rveg to juice, Rveg to turbovec, and turbovec to Rveg, which allows user to work within these softwares together and create the compatible formats. But I will show you that in another video. We can just quickly take a look on these. Rveg to juice will export juice compatible format, also in CSV, but it is readable by juice. And Rveg to turbovec will make the same for turbovec, and you can also convert back from turbovec to Rveg. Alright guys, so I decided that I will also show you how to use the other remaining functions, especially the Rveg to juice function, because I am sure that many of you might want to use this one, and it is not that intuitive, so I'll try to explain. It has 3 parameters. It's the data, checklist, and export. Data is for the database you want to transform for juice. Checklist is use checklist, and export is the name of our export file. So I decided that I will transform the database named merge export we made before here on the line 22, and the output file will be juice export. So there is no interaction with the user, it will just export the file. Take a look how it looks like. Juice export, and we see it's in a format, different one, but this one is readable by juice. But the thing I want to show you is how to insert this in juice as well. I open my juice here, and you see I haven't loaded anything so far. So how to load the Rveg export the juice is to select the import, the table, and from the spreadsheet file. Now we can select the juice export we made before, click open, and now we have to go through this few steps to correctly import the spreadsheet. So we'll just confirm these steps. Used separator in Rveg is comma. Second layer is used as layer information. Now we can double check that we have 4 LOS, 12 species. This is basically correctly recognized table. We see the species names, the layers, and the layer coding is different in juice, so that's the reason for the 6 and 4. And you need to define that the values are percentage. By that, we actually correctly imported our Rveg database to juice. But there is one twist. This was just the species, and there's no header data for the relevant. To insert also the header data, it is possible, but it's quite different process. For this, you have to open the original header file, which is merge export. You need to copy the header characteristics and transpose them, something like this. We need to transpose those. And also you need to rename the ID to relevant number, which our juice is using for recognition of the relevance. And if I copy this, I can insert in juice the header data from the clipboard. Now when I check, I can see that the relevant has its correct header data. There are probably more ways how to do it, but I recommend this way. Alright, the second function from these is Rveg conversion to Rveg. So I have here prepared the export from Rveg, which might look like this, which is also in a CSV format. It has the header characteristic at the top with a space and then relevance. The space is utilized for the layers. So here after this break, it's species data. So we can convert these by this function. There are three parameters. The Rveg file, I just show you name of the export and the checklist we are using. If I run this function, we got a question. Are the data in brown blanket or percentage? It's in brown blanket in our case. And now we have to check if the confirm the correct code for the species. So you can just press enter, check the species. In case, for example, here in the case we don't know the code for the Salix fragilis, we have to find it in the list. And here I can see that for Salix fragilis aggregate, it's Salix hashtag FR because Salix fragilis is fragilis and Salix exuberans. So I go like this, confirm, and continue with the checking process. After I put all the names, I should get the export of the file in the new database, TV Rveg. Let's check the header first. Yeah, it's interesting. There's much more thing now because of the Rveg characteristics. So we can see there are more rows. In some compatibility issues, we can always just delete those. But otherwise, this is the header. So we see 3 relevas, and for the species data, we have the relevas here converted to percentage and the short name codes. We can now check if it works. So if I would be to work with these file, I would just have to specify the database here, Rveg, and I can check print rel, and it seems it works just well. So this is the way how you convert from Turpovec to Rveg. Last function I haven't shown you yet is conversion from Rveg to Turbovec. But unfortunately, I don't have access to Turbovec software at this moment, so I cannot really show you how to load the export to Turbovec. But in the Turbovec manual, there is chapter import data, and you can find the guide there. But I'll show you how you can export from the Rveg to Turbovec readable format. You just have to fill the parameters database and export. We get some warning, but that shouldn't bother us, and we get a result, which is the Turbovec load, and I can see this is the format that Turbovec is able to work. That being said, it was all for this video guide. I hope it's not long enough. It shows you all the basic steps. Explore and experiment with the other functions, arguments, and so on. If you find any bugs, if you have any questions, you can write me an email or write them straight to the comments under this video. The contact information is right now on the screen. Thank you for watching. I hope you'll be using Rveg in future.